Alright, we are going to solve these rational equations. So let's start with this one. To solve this rational equations, you want to use the LCD, and then you're going to multiply both sides by the LCD. So my lowest common denominator, to find it, you simply just take both denominators to start with, and then you sometimes look to see if something in common so you can make it smaller. But in this situation, it's simply just going to be both denominators. Sometimes there's something shared and you don't need to take the whole denominator of both, but this one does. So what I'm going to do here, I'm going to be multiplying this LCD by both sides. And when I multiply by both sides, that means I multiply this, this, and this. So basically everything. So watch what happens. It's going to be kind of ugly looking here. I am going to start with multiplying the x minus 3 times all the pieces, x minus 3 plus x, x minus 3 times x plus 2 times all the pieces. It's going to look kind of funny because what I'm going to do here, actually, let's not do it. Let's just do x, and this is over x minus 3, all right, minus, got to kind of start writing a little bit smaller. Now I have x minus 3, x plus 2 again, and I'm multiplying by the next piece, 3 over x plus 2 equals 2 times the same thing. It's very redundant. Alright, what I did is I multiplied both sides. I multiplied this side and this side by the lowest common denominator in green. And you'll see in a second why that's useful. Because what's going to notice is this cancels with this, leaving you just the top. And I'm going to do distributive property there. So I'm left with x squared plus 2x. I have a minus. Okay, just be careful and put parentheses around that first piece just to keep it organized. You'll see why later. The x plus 2's cancel. And then I'm going to distribute the 3 to both these. Alright, so that would be 3x minus 9 when I distribute that. Okay, and then the back side over here, when I do this, okay, I'm going to FOIL this and leave the 2. So leave the 2, and when I FOIL, this is foiling, you're going to get x squared minus x minus 6. I skipped a step when I FOILed. I noticed that the inside is going to be negative x. If you get better, you start seeing things like that. Anyways, now you should see all fractions are gone. Yay! But it's an ugly quadratic. Oh. So let's solve this quadratic now. So I've got to simplify this side and simplify this side. On the right side, make sure you distribute the negative. That negative now has to distribute. So I'm going to have x squared plus 2x minus 3x, but plus 9. A lot of people forget to distribute this negative to here and make that a plus 9. Oh, it's so commonly forgotten. It's annoying. And then this other side, the 2 needs to distribute. So I have 2x squared minus 2x plus 6. So that's what I have so far. Alrighty. Oops, I made a mistake. That's not a 6. What's 2 times negative 6? That should be a negative 12. So this should be over here, negative 12. My bad. Okay, make that a negative 12. Okay, now, since we have quadratics, we want to get x squared on one side, and we want the x squared to be positive. So in order to do that, I'm going to move all this over here. Real quick, let's combine those, and hopefully you know that's negative x. Alright, so what I'm going to do is I'll move it over. So let's minus the x squared over. Alright, I'm going to add the x over to get rid of that. And then minus the 9 over right there. And I end up with 0 equals, what did I do there? 0 equals, I don't know why I wrote an x there. 0 equals x squared minus x minus, looks like 21. So now I got this kind of ugly equation. Actually, it's pretty nice. It's a quadratic. And I have it equal to 0, so I first think if I could factor this. And if you try factoring this, you'll realize, darn it, I can't. Alright, so let's do quadratic formula. Here we go. Quadratic formula. X equals the opposite of b, so that'd be opposite of negative 1, plus or minus the square root of b squared, so negative 1 squared, minus 4 times a, which is 1, and c, which is negative 21, all over 2 times a, which is 1. All right, let's simplify that. We look like right here we got a negative negative, and here we got a negative 1 squared. So that looks a negative negative is a 1, plus or minus the square root of 1. And then negative 4 times 1 times negative 21 looks like it's going to be 84 positive. That's all over 2 times 1, which is 2. So it looks like my answer is x equals 1 plus or minus the square root of 85 over 2. And this does not look like it can reduce to a nice square root. So this is my final answer. Yes, it's an ugly answer. Now we have to check for extraneous. So 3 would make a 0 here, and negative 2 would make a 0 here. This is not 3 or negative 2, so this will not have extraneous. Most of the time, quadratic formula answers will not be extraneous because they just don't usually make zeros in the denominator, generally speaking. So multiply everything with the LCD. Get this. Now, solve it, and usually it's a quadratic, so you got to get it to e equals 0. Then, if it doesn't factor, quadratic formula. It's a very, very long problem, but you can do it. Hang in there. Okay, the one over here is easier. It's called a proportion. This was a fraction minus a fraction equals something. This is two fractions equal each other, and the way you solve that is something called a proportion, and you cross multiply. So we start off with going, 2x plus 6 times x minus 5 equals, we cross multiply the other one, multiply those. It's called cross multiply. It's done in a lot of other subjects. Whenever it's called proportion, and you just cross multiply when it's a fraction equal to a fraction. Key is fraction equal to fraction. And then we solve this. No fractions left. Hopefully you see some foiling here. So we're going to FOIL this. And over here we're going to distribute. So let's see what we get here. We get 2x squared minus 10x plus 6x minus 30 equals, and on the right side we get 2x squared plus 6x. Alrighty, so now let's combine those before we start trying to solve this. Looks like that would give us what? Let's rewrite the whole thing. So we have 2x squared minus 4x minus 30 equals 2x squared plus 6x. Alright, now let's solve for x. So let's get the x squareds to one side because you have x squareds. So wait, they're both 2x squared. Oh, watch what happens. Oh, this is nice. Watch. The x squareds cancel. Boom, boom. Okay, let's pause for a second. I now have negative 4x minus 30 equals 6x. This is an easy solve. You don't have to get it equal to 0. This is all the x squareds disappear. Be happy when you see the x squareds disappear. This is an easy solve. Yay. Okay, to solve this, let's see. I'm just going to add the 4x over this way because it's a basic solving now. So I have negative 30 equals 10x. Alright, and then I'm going to divide by 10. So I got x equals negative 3. Oh, nice. That came out really clean. Alright, so negative 3 is my answer. Oh, watch out for extraneous. Does negative 3 create a 0 in either of these? Well, negative 3 won't there. That would be 5 would create a 0. But does it create it here? What would negative 3 do? It's negative 3 squared minus 3 times negative 3. That'd be 9. Okay. Oh, it's a plus. Sorry, I read it wrong. 9, minus 9, which is 0. Oh, guess what? This creates a 0. Uh-oh. This answer actually isn't an answer. It's called extraneous. There is no solution. So there really is no solution to this. This answer does not work. It created a 0 in the denominator. Because when I checked it here, bad news. So there's really no solution to this problem. But with these type of problems, cross multiply, solve it, be happy if the x squareds disappear, and check for extraneous. So be careful. Over here, multiply by the LCD. You got to be able to spot these are different. Cross multiply, multiply by LCD. Completely different processes.